on doit multiplier cette fraction. Alors, pour la multiplication, c'est simple, on n'a pas besoin de mettre sur un dénominateur comme l'addition et la soustraction. On doit tout simplement multiplier les numérateurs ensemble et les dénominateurs ensemble. Alors, si je multiplie 2 fois 6, ça va me donner 12. Et si je multiplie mon 3 fois mon 5, ça va me donner 15. Maintenant, cette fraction ici n'est pas simplifiée au maximum puisque 12 et 15 se divisent par 3. Alors, si je divise 3 dans 12, il va rester 4 et 3 dans 15, il va rester 5. Alors, 4 cinquièmes, on ne peut pas le simplifier davantage, alors on a fini. Si on regarde du côté de la division, 5 divisé par 2 tiers, on sait que 5, c'est la même chose que 5 sur 1 divisé par 2 tiers. Alors, on a vraiment une division de deux fractions d'abord. 5 sur 1. Notre division par 2 tiers se transforme en multiplication par l'inverse de 2 tiers qui est 3 demi. Alors maintenant, c'est la même chose que l'autre côté. On multiplie les numérateurs ensemble. 3 fois 5, ça fait 15. Et 1 fois 2, ça fait 2. Alors, dans ce cas ici, on ne peut pas simplifier davantage, mais on a une fraction impropre qu'on peut transformer en chiffre mixte. Il y a combien de 2 dans 15? Il va aller 7, parce qu'on sait que 2 fois 7, ça fait 14. Et puis, il va rester une demi. Et voilà.
So in this video, we're going to look at one type of Egyptian multiplication. And we're going to look at how they went about multiplying numbers and why it makes really good sense. So what did they do? Well, essentially what they did was they took numbers and doubled them over and over again. So for example, let's say they wanted to do 12 times 18. What they might do to figure this out is say, oh, well, 1 times 18 is 18. And then they would double this to 2. So then they would say, well, what's 2 18s? Well, let's double 18, right? Because 1 18 is half of 2 18s. So 2 18s is 36. And they would keep going with this. What would 4 18s be equal to? Well, it's going to be double 2 18s. And in fact, that'll be 72. We keep going. Next, well, first we had 1, then 2, then 4. After that, the next number is 8. What is 8 times 18? Well, we know what 4 18s is. That was double 2 18s, which was double of 1 18. So 8 18s should just be double 72. And how do you double 72? Well, think, what's double of 70? That's 140. And what's double of 2? Well, that's 4. Altogether, that's 144. And then we keep going. Okay, well, what's 16 times 18? Well, that's got to be double 8. And that would be, well, double 100 to get 200, double 40 to get 80, double 4 to get 8. That's 288. Now we're done. And in fact, what we should do is to add the numbers, right? We need 8 18s and 4 18s. If we add up those two, that would be equal to the same as 12 18s. Right, if we picture all the 18s in a row, 12 of them, that's what 12 times 18 means. Well, here we have 4 of them, and here we have 8 of them. So altogether, we do have 12. So if you add these two up, that would equal 12 times 18. And how do we do this? Well, what's 144? We're adding it to 72. So here, 2 plus 4 is 6. 7 plus 4 is 11. Or that's really 70 and 40 is 110. So we put 1 here in the hundreds and the other 1 in the tens, and 200s equals 200. So the answer to 12 times 18 is 216. Now how do you make sense of what they're doing? Well, because they start with 1, that's always where we'll start, and they just keep doubling from there, we're always able to use these numbers in some combination to figure out the product of anything. So for example, let's just say I was doing 13 times 8. Well, then what I would do is I would use what? I would use 1/18. I wouldn't use the 2. I would use the 4, and I would use the 8, right? I would just use 8 and 4 is 12, and then one more is 18. So to find 13 times 8, I can add these three, 144 and 72 and 18. If I add these up, 8 plus 2 is 10, plus 4 is 14, 7 plus 4 is 11, 12, 13, and then 2. So this would be 234. And that makes sense. It's just one more 18 than 216, right? Plus 18. That's because we had now 13 18s instead of 12. So with this method, we start with 1 and we keep doubling until what? Well, notice we didn't need the 16 here, and we wouldn't need it for 14 times 18. With that, we would just do 8 plus 4 for 12 plus 2 more. We wouldn't need it for 15 because we could add all of these, right? To find 15 times 8, I could add 8 and 4 and 2 and 1. But I would need it for 16. So I guess what I'm saying is, what you do, you start with 1, you keep doubling until you reach right before the number, the first multiplicand. I think I'm saying that right. Multiplicand. So you start with 1, you double and double and double, and you can stop before that doubling is going to be greater than this number. So here, I know I can stop at 8 because if I double 8, that's 16, that's bigger than 13, and I don't need to go that far. It's not really a big deal, I can, but then if I double 8 to get 16 18s, right, and get 288, well, that's already bigger than what I need, so it's not going to help me. And in fact, if I had 14, I would still stop at 8 because 8 doubled is bigger than 14, and so is 15. So here, with 12 times 18, I could have stopped at 8, right? Because, well, the next doubling would be larger than 12, and that wouldn't make any sense. So just keep doubling this first column, and don't go larger than the first multiplicand. Otherwise, you'll just have a product that's too large for what you're doing. In the next video, we'll look at some other examples of the Egyptian multiplication method. All right, thanks.